So here are some sample problems. This is for the population dynamics worksheet. So again, I'm not going to do every problem in this worksheet. I'm just going to do a few, give you some pointers how to solve these problems, and then I'm going to leave it up to you to practice. Make sure you're checking your answers and making sure you know what you did wrong. So number 1 says a certain population is experiencing exponential growth, and it gives me the population size, the births, and the deaths. So the first question says calculate the individual growth rate R, which is also known as the per capita reproduction rate. So from the top, we're going to find that the equation for growth rate R is going to be B births minus D deaths over N. And N is always going to be the population size. So I'm going to take this, and from the top, I'm going to find that the births was 10, the deaths was 4, and my N, or population size, was 50. I'm going to do some math, right? That's going to come to 6 over 50, which is going to give me an R value of 0.12. Since this is a rate, it has no unit. Then part B says calculate the population growth rate, the individuals added to the population in one generation. So again, I'm going to look on top for the equation, and I'm going to find the one that is delta N over delta T. And this together is the growth rate here. It's like rate is like speed, distance per time. This is going to be the change in N, or the change in population over the change in time, is going to equal the rate times the population. Because it's delta N over delta T, think of that as one variable. All I need to do is do the rate, which I just found to be 0.12, times the N given at the top, and I'm going to get a population growth rate of 6. The unit here would be the population over the time. It's okay if you just leave it blank though. So this problem says, now consider population D in which food resources are limited and it's experiencing logistic growth. That's going to be important, that it's logistic growth. It gives you the population size, which is N. It says R from the previous problem, so you need to look at number 3 and discover that the R value from number 3 is going to be 0.14. I'm going to write that there so I don't forget. And the carrying capacity is going to be 1,000. Carrying capacity, remember, is the K. First part A says how many individuals would be in the population at the start of the second generation. So what I'm going to do is I'm going to use our change in N, change in individuals over change in time equation. And that's going to be Rn. And then the equation that includes the carrying capacity K. So this is the only equation that's going to put together the rate, the N, and the K. From here, I'm going to plug in what I know. So again, I know the R is 0.14. I know the N, or population size, is 500. The carrying capacity K is 1,000. Then again, the population size is 500. So I'm just kind of plugging those numbers that I was given in. Okay, and I'm going to solve all this. So I'm going to multiply 0.14 times 500, multiply everything in the brackets, and I'm going to get a change in N over change in T rate of 35. So you're changing by 35 individuals at a time. This is not the answer to the question, though, because the question says the second generation. So if the original population was 500 and the rate is going to be 35 individuals per unit of time, I'm going to do 3,500 plus that 35 to give me 535 individuals in that second generation. If we look at part B says how many individuals will be in the population at the start of the third generation. And again, you're going to kind of use the same math. So the only difference being is that your N, population size, is now 535, but you're going to see something kind of crazy happen. So if we do delta N over delta T, same equation. Notice the K and the N, the K stays the same, the N's going to change. So the rate is the same, 0.14, but now I'm going to put in 5 535, because that's your new population. So I'm going to do 1,000 minus 535 over 1,000. And when you do all this math, you actually get a delta n over delta t that is also about 35. So if you took a shortcut and you just did 535 plus 35, you would have still gotten the correct answer, which is this next generation is going to be 570.